times RT plus 1. This is the reward or the feedback. And then you have max, okay, and A, and this is Q ST plus 1A, okay, and this is a smaller this thing, minus Q ST AT. All right. So this is my formula. And QLearning is all about this one formula only, right? And only one value gets updated in the whole of QLearning algorithm, and that is the Q value for each cell, right? So there are no other things that we need to look at. So this is an interesting fact about the QLearning algorithm. So now let me tell you about this. So Q value is basically, it indicates the utility of a state. So it has got two parameters, ST and AT, right? So ST is basically the state at which in which you are currently in at time t, right? And AT is the action that you take from that particular state, right? So in this grid world, so you can take 4 actions, right, from each state. So that's why each cell has been divided into four smaller cells, right? So this is the value that I update. This is the old Q value, and I also told you in the last class that this is an implicit formula, right? Okay, and then this alpha is called the learning rate. So I'll talk about this, and then this is the reward or the feedback. Okay, then this gamma is the discount factor, right? And okay, so this is something you maximize, right? So maximum future Q value. So this is what is maximum. And this is again the old value. Okay, so this is how this formula looks like. Okay, and in QLearning, you are just using this one line of code actually to do everything. All right, so let us now talk about this. So alpha. So let us first talk about alpha. Okay, so what is this alpha? So let me. Hello. Yeah, so let me just talk about this alpha. All right, so alpha is the learning rate. So how do you see this? So decides how much future actions should be taken into regard. Okay, so how much future actions should be taken into regard while taking a decision. So if alpha is 0, if alpha is 0, right? So let us look at the two extremes. Alpha is equal to 1. So if alpha is equal to 0, that means the learning rate is 0. That means you are not learning anything. So you are not learning anything new. So that is how you interpret it. Not learning anything new. And alpha is equal to 1. That means only the most recent value is considered. Okay, so these are the two interpretations for the values, extreme values of alpha. So alpha 0 means there is no learning. Alpha is equal to 1 means only the most recent value is considered, right? So now let me come to gamma. So gamma determines how much future reward is taken into account. So I'll give you some examples, right, through which you will be able to understand this. So gamma is equal to 0, say for example. So if gamma is equal to 0, that means I am not concerned what is going to happen in the future. All right. Say if you talk about the dots and boxes game, right? So I will only look at whether this particular move is going to give me a box or not, right? I am not concerned about whether I win or lose in the end, right? So that is what is gamma 0. Gamma is equal to 1 means long-term high reward will be prioritized. So gamma is equal to 1 means long-term reward will be prioritized. So I'll not worry too much about whether I am losing a box right now, right? But if I take gamma to be very high, that is almost close to 1, right? Then it says that you are trying to prioritize your long-term reward. All right. So this is what is this. This is what it does, right? And uh, I'll also talk about uh, different kinds of agents that you can use. So we already know the concepts of agents. So let me introduce it here again. Okay. So agents. So one is a QLearning agent. Okay. Then the second is a random agent. And then there's a simple agent. Okay, so you understand the difference between these. Random agent we have discussed, simple agent also we have discussed earlier in the course. So Q learning agent means it uses the Q learning algorithm. Okay. Then the random agent is one that makes random moves. Okay. And simple agent is it acts as if there is no opponent, right? So it'll not be concerned about what move the opponent is making. So it'll only make the same kind of moves or using the same kind of strategy, same move, right? So let me give you an example that it'll draw a line. So if you are talking about a dots and boxes game, draw a line with minimum number. Okay, so we named we gave numbers to the lines in the dots and boxes games. So what you do is whichever minimum number line is available, I'll put a line there. All right, so these are the three things that you need to understand right now. Okay, so let me now give you something about let me give you some idea about the rewards as well. Okay, so rewards are actually, you can give only a final reward, right? That is when you win or lose, at that time you give a reward. Or when you finish a box, you are given a reward. And also when you win the game, then also you get a reward, right? So let me give you some situations, right, which will help you understand different aspects of Q learning. So let me, I'll have to draw those. Yeah. So let me draw excuse me, 4 by 1, 2, 3, 4. 1, 2, 3, 4. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Right. So for 16 dots and 9 what? No, 16 dots and how many lines? I think there will be 24. 24 lines. Okay. Now let me give you a particular state of this game, right? So okay, this is good, this is good, right? This is also there. Okay, and then this is there. So this is a carefully chosen state. Okay, this is this game, right? So now, okay, so you are player 1. Say again, let us play a game. Player 1, okay, and player 2. So player 1 is is using green ink, and okay, player 2 is using red is there, I said black. Okay, all right. So it is like this. Suppose player 2 makes a move, right? Okay, so what he does is he tries to draw this line here. He closes one box. So as and when you close a box, right? So you write your name there. Okay, so 2, and then your next move is again yours. So he again goes here, makes a 2, and again goes here, makes a 2, and again makes a move and draws a 2 here. So he gets 4 boxes. But now, since he has marked he's closed a box, next move is also for player 2. Player 2 has to make the next move. So let us see. He makes a move here, right? Now, what happens? So let me change the color. Okay, so green. Now it's the chance of the green player. So he draws this line here and writes one here, closes this, writes one here, closes this, writes one here, closes this, writes one here, and closes this and write one here. So you can see that player 1 has won the game, right? And player 2 has lost the game, right? So what happened here was that player 1 was, player 2 was actually greedy, right? He wanted to close as many boxes as he could without thinking too much into future. All right. So and he ended up losing the game. All right. So this is one situation. Okay. So now I hope all of you are able to understand this. Sorry. Yeah. All of you are able to understand this. Now let us play this game again. Okay. So I'll have to draw it again. So let me use the black for drawing the grid. Okay, so you have this 1 2 3 4 1 2 3 4 1 2 3 4 and 1 2 3 4. Again, the situation is the same. So you have these lines drawn. Let us not worry about who drew this line. What is important to us is whose chance it is, whose turn it is to, right? So suppose again it is player 2 and he's using what color? So player 2, let us make him use red. Okay, so it is player 2. So what he does is he makes this box and calls it 2, and then he makes this box and calls it 2, right? You can see that he could have closed these 2 boxes as well, like he did in the previous game. But now he does something different. He says that, okay, he'll mark this. He marks this, right? Okay. Then what? Then player 2 comes. Player 2 is green. So, oops, sorry. Player 2 is green. So he comes and does what? He marks this and marks this. Now what? He has to make the next move. Yes or no? Okay. So where? I think no, this one is not there right now because 2 boxes. So the red one will. Okay. I think I made some. So this is not there. Suppose. So 1 2 3 4. 1 2 3 4. Okay. So just let me check one more time. These 2 are there. Okay, let me remove something from here. I think I made a eraser. Just a minute. Okay, so he makes these two moves, 1, 2, right? Okay, this one is not closed, right? So this one I'll remove, right? So I'll remove everything right now. Just a minute. Let me start with red. Okay, so he marks 1 here. Yeah, so this is not marked. So he marks 1 here. So this is 2. Okay, and this is 2. He closes this, and then what he does is he marks this particular move. All right. Okay, and then the green player comes. I hope I get it right this time. He marks this, and yeah, and he puts 1 here, and then he marks this, right? Okay, and then now again 2 will come back. Okay, and then it'll close everything here. So 2, 2, 2, 2, 2. Are you getting this? So in this particular case, 2 was not greedy in terms of immediate rewards, right? So he strategically placed a line here, right? So that eventually he can win, right? So this is how you play this game. Now, if you were to train a Q agent, right, to do all of this, so how will you do that, right? So that is what we'll be discussing. Okay. Now, I was telling you about the action selection strategies. Right? So, okay. So one is that, so how do you introduce uh, exploration into all of this? Okay. Okay. So how do you do that? So as I told you that each box has say 4 things, and you are always going with the maximum value, right? Whatever is the maximum value, right? So you're always choosing to move in this direction. Okay, so this is what? This is purely what we call as exploitation. So I'm now trying to discuss this exploration in context of the Q values, right? Okay, so this is what you're doing, right? So in exploitation, the probability of choosing the best option is always 1. Okay, and the probability of choosing something that is not best is always 0. So all these have 0 probabilities of being picked up, right? Okay, so if you recall, so this is what is called as the greedy one, right? So now if I talk about epsilon greedy, okay, so epsilon is the probability, small probability, which allows me to choose an option which is not the best, right? So if I take you back, so let me okay, write down some values in a particular cell, right? Okay, let me draw it here itself. So suppose there is a cell here. I'll draw it slightly bigger, right? Okay, and these are the 4 values. So this is 0.918, and it takes you to the winning state or +1 reward. Okay, and then the other values are 0.881, 0.8, what is that, 12, and here it is 0.675. All right, so now suppose I'm using the greedy approach. So greedy approach will always take you here. There is no issue with that, right? Okay. So let us now talk about epsilon greedy in the context of the grid world, or in context of the QLearning aspect, QLearning algorithm, right? So what I do is I say that, okay, what should I say? With probability 0.85, I'll go in this direction, okay? Not percent, 0.85 probability, and remaining probability is 0.15, so 0.05 for each. So 0.05 here, 0.05 here, 0.05 here, right? So all of them, irrespective of what is their utility, they all have the same probability of being picked up, right? So when they have the same probability of being picked up, right, it is possible that you pick up the worst of the options that are available to you. Is it not? Do you agree with that? Yes, please. So do you agree that in epsilon greedy, since all the alternative options, or not the best options, have the same probability of being picked up, right? So it is possible that I actually pick up the worst option in terms of the utility, or in terms of the Q value. Yeah, is it possible? Are you guys able to hear me? I hope I'm audible. I forgot to do the recording. That's fine. Yeah, are you guys able to hear me?
Yes, sir.
Okay, okay. I was not hearing anything, so I thought there is some problem. All right. So you understand the problem with epsilon greedy, right? So first of all, you need to understand the problem with greedy also, right? So greedy, there is no exploration, so that's a problem. In epsilon greedy, there is exploration, but there are chances that I'll choose the worst option that is possible, right? So there is a problem with this. So how do I fix these problems? I want exploration, but at the same time, I don't want, I want to minimize the probability of picking up the worst value or the worst option. So what do I do? Okay. So what I do here is I do the softmax selection. Okay. So what this softmax selection means? So let us try to understand that. Okay. So again, there is a best option. So 0.85. Okay. And then there are these three options. So let me write down the values for the other three. So in the decreasing order, says 0.918, 0.881, 0.812, and 0. How much? 675. Okay, so let me erase a few things from here so that is less clutter. Okay, so, oops. Just a minute. Yeah. Okay. All right. So I have to select the pen again. Okay. So these are the four options, and these are the four Q values that are associated. This is maximum. So I say that I attach a probability of 0.85 to this. All right, like in the previous case, like in the case of epsilon greedy. So this is softmax. Okay. Then what I'm left with is 0.15, right? Okay. So I say that this one, the second best, takes a good chunk of what is remaining. Okay. Then the next best takes, so how much is left? 0.05, right? So 0.04, and this is 0.01. So this adds up to 5, 4, 9, 1, 10, 8, 9, 10. Yeah. So this adds up to 1. All right. So what I have done here is that I have given the rest of the options a probability which is based on their value, right? So a good Q value here would say 0.881, so it attracts a higher probability, right? Similarly, 0.675 is the worst one among the 4 or among the 3, so it attracts a very less probability of 0.01. So once you do this, you take care of the problem which is there in absolute greedy. All right. So now the probability of 0.675 has come down from 0.05 to 0.01. So I am minimizing the probability of picking up the worst option. All right. So this is what is the softmax aspect of the QLearning, or any algorithm where you have to do some exploration, right? So these three things: greedy, right? Epsilon greedy, right? And what? And softmax. So these are options available to you where you want to do a mix of exploitation and exploration. So wherever in any algorithm, in any AI algorithm, whether it's a search algorithm, so or it is a Q-learning algorithm, right? So Q-learning is also a kind of a search, right? Okay, so you're searching for a path. So you should think in terms of these options. So typically, a Q-learning algorithm would have 3 parameters. So one is alpha, one is gamma, and the third is epsilon, right? So these 3 things define a Q-learning algorithm. And as I told you earlier, this is right. So this is just a one-line algorithm where you have to keep updating the Q values. So you start off with a blank slate. Blank slate typically means that you have a Q value of 0 for each state, and then you kind of start refining these values, right? Okay. And when this Q-learning converges, right, so you get a value for each cell and for each action. So you would know here that there are 9 cells in this, like the problem that we were discussing. No, not 9, 1, 2, 3, 12. 12 cells, right? And there are 4 actions in each. So, right, so there will be in all 48 Q values, right, that you need to worry about. But this number can grow exponentially. Like even if you look at the dots and boxes games, dots and boxes game, right? The number of state action pairs would grow exponentially as you increase the number of dots. All right. Okay. So now tell me, have you understood what is Q-learning? What is MDP? What should be the action selection strategies, what are alpha, gamma, and epsilon in context of the Q-learning algorithm? Yeah. Any questions that you have on this? Yes, please. Any questions? All right. So let me, if there are no questions, so let me take you back to the presentation. All right. So let me close this and show, and let me open reinforcement learning. Yeah. So I'm not feeling all that comfortable today, but I'll just take a few more things, discuss a few more things, and then I'll close. Okay. So let me see where I wanted to be. Yeah. So, okay. So this is the game that we are discussing. So let me, simple agent, we discussed this already. Okay. Right. So we make, so let me take this, stop here and do this. So what is the role of simple agent? So you can say that this is not doing anything. So I mean, it's a kind of a very stupid agent, right? It always looks for the line that is minimum numbered, right? So what it does is basically, so we pitch the Q agent with the simple agent, okay? And what it does is that it gives the Q learning algorithm an easy and predictable opponent to play with. Right, so that's the purpose of this. So whenever, say, you are also practicing for a tournament, right, so you want to play with different kinds of players, right? So typically, so I am a left-hander, so um, uh, people are not used to playing with left-handers that much, any game you take, right? Because the number of so there is a kind of a skew, like there are not many players that are left-handers, beat any game. So if you play with a left-hander, right, so you learn new things, right? And similarly, if you play with a person who's more attacking, right, and then you also play with the person who's more defensive. So you try to play with different kinds of uh, players to learn, right? So that's what, right? So we have these different kinds of agents in game playing where you want to play. So you know that suppose you are playing cricket, right? So okay, and you are a bowler, right? And you are bowling to a batsman, and you know that this batsman is always going to hit on the leg side, irrespective of where you pitch the ball, right? So you know what this player or what this batsman is going to do. So you can think in terms of how to get this player out, right? So that kind of thing, right? So we have already discussed these state space and state action pairs and all of that. So I'll not spend too much time on that. And let us quickly look at this reward part. So positive or negative reward only when the game ends. This is one kind of reward, right? Okay. And positive or negative reward when the game ends, and also when a box is completed. So when your box is complete, you give the person a very small positive reward, right? Reward for winning. So how should you decide on the reward? So that is what is important. So reward for winning the game must be greater than for completing a box, right? Okay. So if I again take the example of cricket, so there's a player in your team who scores a century, right? Okay, but the team loses, right? So there's a typical analysis that people give these days. If you follow cricket, right? So how many times a player has scored well and the team has won, right? So the opposite of this is that how many times a player has scored good, but the team has lost, right? So those kind of things come in here. So there are a lot of things that you can relate to game playing, any kind of game, right? Okay. And likewise, the punishment for losing a game needs to be more severe than losing a box, right? Okay. So same kind of things here. So this is the reward kind of, this talks about the reward aspect. Okay, it's not moving. I don't know what is wrong. Just a minute. Yeah. And this is the formula that I discussed with you, right? So you always update this. So let me now give you one more aspect of this, right? One more aspect of this formula, and that is quite interesting also. So you should understand that part. So let me, I'll need a blank screen for that. Just give me a minute. Yeah. So let me draw it here itself instead of, yeah, I'll do this. So what color? I have to choose a color that is light, right? So again, what is Q? I'll just write, I'm doing away with the time thing, right? So it doesn't make any difference. QSA, right? Okay, so let me not write it as assignment. So let me write it like this, plus alpha times RT plus 1. So let me write down here. This will not, otherwise it will create problems. Plus gamma times max of Q, max of A, Q of ST plus 1, comma A minus Q ST AT, right? So this is what it is, right? Now, suppose I take active learning that is almost close to 1. Oh, not active learning, the learning rate, sorry. The learning rate is almost close to 1. So what I can do is this whole thing becomes approximately equal to QST AT plus RT plus 1 plus gamma times max over A Q ST plus 1 comma A, right? And minus Q ST AT. All right. Okay, so now what happens? This gets cancelled with this, and this is equal to RT plus 1 plus gamma times max Q ST plus 1 comma A, right? So now what? So what can you make out from this? Yeah. So see this simplification, and we are assuming that alpha is equal to 1. So you know how we interpreted um, alpha is equal to 1. Yes, anyone can give me some idea what is happening here? Yes. So okay, so let me so why I wrote all of this is because, see, what we are saying here is that in Q learning, the role of gamma is more important. So I'm making a statement than the role of alpha. Okay, and this you can actually show through some experiments. Okay, so I'll now tell you something about what you need to do, right? So as part of your assignment. All right, so let me, I'll put up a formal statement to the assignment on Nalanda, but let me, so implement any board game. using QLearning. Okay, so that's what you need to do. Okay, as part of this assignment, right? So you can choose to work with the what do you say, the dots and boxes game, or you can pick up chess, right? But chess would be computationally quite expensive, right? Okay, so I think you can go with the uh, uh, what? Go with the dots and boxes games. Dots and boxes is okay. Have you understood it? So will you be able to implement dots and boxes game? So what you need to do is input would be how many dots, number of dots, and so once you decide the number of dots, you also decide the number of lines. So that should be your input, right? And you should train a QLearning model, right, on this, right? So what you can do, you can try different things like QLearning agent. Oh, sorry, what happened? Oops, I lost that. Anyway, so you can train this QLearning against a random agent. So that is one thing. So QLearning, so how you'll train it? QLearning versus random. So that is one possibility. The other possibility is QLearning versus another QLearning. Okay. Then what you can do is, well, let me tell you, just hold on. To just a minute. Yeah. Then QLearning versus simple agent, right? Then what else you can do? Yes, suggest anything else you can do. Okay, so now what you can do is one of these trained. So what you are doing in all of this is you're training a QLearning algorithm, right, or Q agent. So you'll get different Q agents here. So suppose this is Q1, this is Q2, this is Q3. Now you train any one of these with a new training agent, new QLearning agent, right? So all of this you can do, okay? And what you need to do is you need to keep varying alpha, you need to keep varying gamma, and then see what comes out. And then as far as action selection, you can implement three aspects: greedy, epsilon greedy, and of course softmax. So this also you should be able to implement. All right. So I'll put a formal statement for the assignment so that you can go through it and complete this assignment. So how much time you would need? 3 weeks, right? And teams of 2 is fine. Yeah. Teams of 2 is fine. Yes, please.
Yes, sir.
Okay. So there are 50 odd students. So a team of 2 should be fine, right? So this is what you have to do. And if you want to pick up any other board game, I'm fine with it, right? Okay. So I'll not mention any particular board game in the assignment so that you're free to implement, right? So QLearning will help you understand a lot of, like when you implement QLearning, you'll learn a lot of things which will help you uh, a lot in designing bots and right. So QLearning or reinforcement learning is used a lot in bots. So you will be able to learn a lot of about, I mean, you can see a lot of applications. You'll be able to appreciate a lot of applications of QLearning in robotics. right? So that's with that thing in mind, I've decided on this particular assignment. All right. So I'll close, and please wait for the assignment to be uploaded. And if you have any queries once you see the assignment statement, please feel free to write to me.
Sir, what will be the deadline?
I'll give you around 3 weeks from the date I put it up.
Okay, sir.
3 weeks should be fine, right? Because then
Yes, sir.
we'll run into Compre and other things, right? So I want to wind it up before that. All right.
Yes, sir.
So you can start working. I have told you what you have to do. You have to work on QLearning. You have to work on a board game, and you have to do the complete implementation with lots of analysis so that you understand what to vary, what not to vary, and how much to vary, and all of that in terms of alpha, in terms of gamma, and of course also in terms of the epsilon part, right? So these are the only 3 parameters that you have. Okay. So you can try to analyze that how good your QLearning algorithm is, right, for a particular problem like dots and boxes, when alpha is high, gamma is low, right? Or when alpha is low, gamma is high. All those kinds of things you can analyze, right? So because all those things I cannot be discussing like in the class, right? Because there are too many things, too many options that you have, or too many combinations, right? So best way is to implement these algorithms and do some analysis, right? So that is the best way to understand, right, this. And then I want all of you to do it in C or Java. I don't want Python and other libraries that you should use, right?
Can we use C++?
C++ is fine. I mean, right?
Okay, sir.
C++ is fine. I don't want you to use a very, very high level language like Python, right? So because everything is inbuilt there, you don't learn anything, right? You don't know what is happening. QLearning will remain a black box for you if you do Python, right? Okay. Is that all right? So I'll close now and wait for the assignment to be put up. And when is your QT3? Any idea?
For AI, it's on 19.
AI, it is 19th. Okay. My other course is on 11th. Okay. So we have time. And early next week, you will get your first test also evaluated, right? And whosoever has given for recheck for test 2, I'll be doing that in one go, right? I'll not respond individually, but I'll update your marks if there's any change, and then the updated marks will be communicated to you. All right? Okay. So with that, I'll close.
So,
Right?
sir, what about makeup for test 1?
Sorry?
Sir, what about makeup for test 1?
That I'll schedule. I'll let you know. Right? So you
Okay,
keep
sir.
looking for Nalanda. Right? The notice will be put up.
Okay.
Okay.